the thread that we're really looking at, or the direction that we're looking at this developmental aspect from, is really the angle of what it is to be an animal in the sense of animal welfare. We spend a lot of time as legislators and as lobby groups thinking about animal welfare and addressing what we see as problems within animal welfare. And in order to do that, we need to have a model of what it is to have the capacity to feel pain. So when we look at animal welfare, we start off with what is an animal. And this is what Wikipedia says an animal is. And that's fine. And Wikipedia also provided the nice picture there with lots of examples of animals. But in my mind, not all of those animals have the capacity to suffer pain and emotional hardship, and therefore not all of those animals need their welfare protected. So that, for example, this chap here, standard mammal, definitely has the capacity to perceive pain and to suffer from compromises to his care resulting in poor welfare, whereas this chap here down the bottom, I don't really have a concept of how any suffering on his half can lead to a compromise in his welfare. And in fact, I have no problem if he happens to be living as a parasite in the liver of a sheep in giving the sheep some drugs that will result in his horrible death. I don't worry about the suffering of those worms when I'm treating the sheep. So in order to look at animal welfare, we need a different definition of what is an animal. And when I'm talking about an animal in terms of animal welfare, I'm not talking about multicellular metazoa. I'm talking about something different. And to find that definition, we need to look into the animal welfare legislation. There are two parts of the acts which are relevant, and this is the New Zealand Animal Welfare Act, but it could easily be the Animal Welfare Act of just about any other country in the world. The Australian Act, the British Act, most of the European acts, the acts in the States, all have similar predications. They don't all carry the same tight definition of which animals are included and which animals are excluded, but they all have the same principles. So Part A of the definition of animal in the New Zealand Act talks about a member of the animal kingdom that is a mammal, a bird, a reptile, an amphibian, a fish, or certain kinds of invertebrates. And what we're looking at here is a certain complexity of animal. These animals have a sufficiently complex nervous system that we have a concept that they can suffer. And so they are included as animals in the Act. Parts B and C of the New Zealand Act are talking about life cycle. They're talking about any of the animals in Part A that is in the second half of its gestation or development. So for a mammal, the second half of its gestation period. For a bird, the second half of the period that it spends in its egg. And C specifies that it includes any marsupial pouch young. So we're now looking at a definition which is a species of a certain complexity and also includes a stage of its life cycle where it has achieved that degree of complexity. The key concept then is the ability to suffer. The word suffer is fairly emotive, and some people working in welfare use the word deliberately and really like it. I'm one of those. Other people say, well, suffer carries all sorts of other emotional baggage and we really shouldn't be using a word like that for animals. So I just want to say that when I use the word suffer, what I mean is that a noxious stimulus may have a negative impact on the animal's welfare. So again, going back to those very simple animals, a noxious stimulus on one of those very simple animals probably wouldn't have a negative impact on the animal's welfare. But when we get to the animals covered by the Act, certainly we're getting into the realm where we need to be careful about that because of welfare impacts. So this is my working definition of an animal in a welfare sense. This is what I think that the animal welfare legislation is reflecting in its definitions of what is an animal. And it contains those two components. An animal of a sufficiently complex species and an animal at an appropriate stage of its life cycle, such that it has this capacity to suffer. One of the things that my research group is interested in are where are the limits of pain. And in order to give you an idea of where we're going with that in the two different directions, I just want to show you some animals in the metazoa sense and talk to you about their suffering. So this is one of the most simple animals that you can find. This is a sea sponge. Okay? It's multicellular, it's eukaryotic, it's metazoan, it's an animal. Do we think it has a capacity to suffer? This is a cheetah, standard mammal. It's there as a representative of the mammals, really, but I happen to like cheetah. Do we think that that animal can suffer pain? Hands up. Yeah, so pretty much we've got nobody in the room thinking that pain and welfare is a problem over here, and everybody in the room thinking that pain and welfare is a problem over here. So there must be somewhere between these two levels of complexity where welfare first becomes an issue. What about this chap? Now, I've put this trout up not because I think this is necessarily where the piece of paper should be placed between animals where welfare is an issue and welfare is not an issue, but because the trout is the subject of quite a protracted public debate in New Zealand and worldwide at the moment between a group of people that say these animals don't suffer pain and therefore we can fish them with a rod and line and we can have a great time in the great New Zealand outdoors of a weekend and come back with something for the barbie. And another group of people who say it's barbaric to hook those things through their upper lip and drag them around a river for 20 minutes and then pull them out and knock them on the head. So there's a debate there about whether or not recreational fishing, and any other kind of fishing for that matter, is a welfare issue, and it hinges on the fish's capacity to suffer. If we believe that the fish has a capacity to suffer, then recreational fishing doesn't look very pleasant, really. And if we don't believe the fish has a capacity to suffer, then recreational fishing, not a big problem. So that is the phylogenetic issue of which animals are effectively in the pain club, as Paul Flecknell at Newcastle described it. Which animals are in the pain club? Which animals are we concerned about their ability to suffer pain? The other issue about the limits of pain is the ontological, life cycle limits of pain issue. So here we have a drawing of an 8-cell stage human embryo. Nobody debates that a human has the capacity to suffer pain. Nobody debates that welfare is an issue for human beings. Do we think that this 8-cell stage embryo has the capacity to suffer pain? No? People shaking their heads? Everybody happy with that? This is Charlie, the same organism, a member of the same species, but this time about 18 months after birth. Certainly had the capacity to cause his parents a lot of pain, but that's another story. Do we think that Charlie has the capacity to suffer pain? Hands up? Yep. Everybody happy with that? What's interesting is that until about 20 years ago, clinical medics, doctors, didn't believe that humans like Charlie had the capacity to suffer pain. They believed that the ability to perceive and suffer pain came along at about the same time as language developed. And so Charlie at this stage was on the edge of language, but he wasn't actually able to hold a conversation. And so had he needed a piece of surgery 20 years ago, then he would not have been deemed to require pain relief for that surgery. And in fact, that was really only changed and refuted in the mid-80s when Sonny and Ann came along and demonstrated that newborn babies had the capacity to respond to noxious stimuli as if they were painful. He looked at stress responses, at cortisol increases. Subsequently, people have looked at behaviour, people have looked at long-term prognosis and long-term after effects, and demonstrated that children after birth and before language have the capacity to suffer pain. This is a late-stage human fetus in a uterus. And again, I put this one up because this is not necessarily where we need to draw the line, but this is where the debate is at the moment. If this child had been born prematurely and was in a special care baby unit, then orthodox medical opinion would say that absolutely that child needed analgesia if it was to have anything unpleasant done to it. But when it's in its uterus, it's in a very different environment. It's warm, it's fluid-filled and buffeted, it's relatively hypoxemic and hypercarbic. It has an increase in lots of hormones like the pregnenolones and the allopregnanolones that are effectively anesthetics, and it's not currently known whether or not babies in the uterus at this kind of stage of development have the capacity to suffer pain and therefore need analgesia. It is becoming important to find that out because increasingly babies at this stage of development are being taken out of the uterus to have life-saving surgical procedures and then put back in the uterus to stay within the uterus until they reach full term. And that kind of surgery has amazing results. There are people walking around who, as babies, had cardiac anomalies that were incompatible with life outside the uterus and would have died at birth 10 or even 6 or 7 years ago, but now can have that kind of surgery, can have their heart replumbed in utero to give them a heart that's compatible with life and then can be born normally. And children with facial disfigurements, particularly hair lips, can be operated on at this stage of development, and the surgical results are fantastic. At the point of birth, you wouldn't know that those babies had ever had a hair lip. Their healing in these very young fetuses is dramatic. But the question remains, do they need analgesia for that surgery? Because the side effects of analgesia are such that if they don't need it, it's better not to give it to them. But if they do need it because of their welfare and because of their subsequent development, then we need to find out about it and give it to them. So those are the two issues about where the limits of pain are. What we did in order to look at the ability to perceive pain was to look at 3 groups of mammals. We wanted to look at precocious mammals, mammals which are born at a very late stage of development, and we chose the lamb for that. Altricial mammals, which are born at a much less well-developed stage, and we chose the rat for that. And we also had the opportunity to look at the Tamil wallaby joey, which is a very altricial mammal. At the point of birth, the central nervous system of the Tamil wallaby has about the same stage of development as a 40-day-old human fetus. So it's very, very poorly developed at birth. We'll start with the Tamil wallabies, the very altricials. And this is what we know about Tamil wallabies from the literature, or what we knew when we started the study. Their eyes and ears open at about 140 days after birth. They can stand unaided at about 160 days after birth. They start to look out of the pouch at 180 days. They leave the pouch for the first time at about 190 days, and the entire pouch phase is around about 260 days in the Tamil wallaby. So they have a very, very early birth. And this is what they look like at birth in the top corner. This is a wallabean, as we call them. And they stay in the pouch late on. This is a wallaby joey at about the time that it first ventures out of the pouch. So it's a huge developmental stage that goes on outside the uterus and inside the pouch. And what we wanted to know was, at what stage during this development do these animals develop the capacity to perceive and suffer pain? So we looked at EEG responses to toe clamping, a noxious stimulus, in joeys between 95 and 260 days. This is the typical look of a joey at about 95 days. And here we have a much later joey, which is just about to leave the pouch for good. That's right at the end of its pouch phase. We anaesthetise them, with a particular technique that we've developed which allows the electroencephalogram, the electrical activity of the brain, to respond to a noxious stimulus even though the animal's anaesthetised. And we applied a toe clamp and looked to see if we could get any changes in the electroencephalogram in response to that toe clamp. What we've found in adult mammals and what other people have found in humans is that that EEG response relates more to the perception of pain than to the application of a noxious stimulus. And so it's a change that correlates with how painful the human or animal perceives something to be, rather than the size of the noxious stimulus that was applied. The electroencephalogram is isoelectric until about 120 days. There's no electrical activity in at least the forebrain until about 120 days into the pouch phase. And it's continuous by about 140, 160 days, and over time there's an increase in EEG power. The response to clamping is small in joeys between 140 and 180 days, and much larger as the joeys get older, from about 190 days up to full term. And so our results, together with the results of the literature, suggest that perception is not likely before about 120 days, and that it's certainly present by about 160 days. So we've got this grey period that we're not sure about, but for a large part of the early pouch phase, it seems that these animals are not able to perceive pain. Rat pups are born neurologically moderately immature, and they do most of their main developmental steps after birth, but a lot sooner after birth than the Tama wallaby. So their ears and eyes are opening at about 2 weeks, and by about 3 weeks of age, they're play fighting. And interestingly, their EEG differentiates into REM and non-REM sleep at about the same time, at around about 3 weeks of age. So we did the same study in groups of rat pups. From very young rat pups up to much older rat pups, we anaesthetised them, we applied a noxious stimulus, and we looked at the response. So here is a very young rat pup, anaesthetised and with electrodes placed in the scalp to record its EEG, and again a much older rat pup. So in the case of the rat pup, the electroencephalogram is isoelectric for the first week of life or so. No electrical activity in the forebrain until the animal's a week old. We get a moderate response to toe clamping by about 2 weeks, and a strong response by about 3 weeks, and we see the same increase in EEG power with age. And again, taking our results and the literature together, we're suggesting that conscious perception is not normally present until about 2 weeks after birth, when this response starts to develop. And that rat pups from 18 days old are capable of conscious perception. And again, there's this grey area where pups between 12 and 18 days might have some kind of conscious perception, but it probably isn't the same quality as the kind that the adult rats have. Let's go on to look at lambs. Again, lambs are born neurologically very mature. Their ear canals and their eyes open in utero. And they also differentiate REM and non-REM sleep at about 80% of gestation, again in utero. And soon after birth, they have volitional responses to maternal environments and stimuli, and they establish sleep-wake cycles within a day or so of birth. So we looked at lambs, and the noxious stimulus that we used with lambs was the stimulus of castration, which is a routine animal husbandry practice. So again, the animals were anaesthetised. Scalp EEG electrodes were placed. And then the noxious stimulus of castration by the application of a tight rubber band around the scrotum and the testicles was carried out. And we looked at the EEG response in lambs from 3 hours of age, which was about as young as we could carry this study out and then get the lambs back to mum afterwards, to 36 days after birth. The results down here show you the response of one of the EEG variables that we look at over the first week of life. And it's the change in EEG. So 100% is no change. The EEG stays at 100% of its pre-stimulus value. And you can see that in the first few days of life, there is very little response in that EEG variable. But as we get up towards the end of the first week, and certainly by the time we get up here to about 10 days of age, there is a response in that EEG variable which is of the same order of magnitude as the response to a noxious stimulus in an adult sheep. So even though these animals are hitting most of their developmental parameters before birth, they're still only developing this ability to perceive a noxious stimulus in the first week or so after birth. We also looked at changes in EEGs in conscious lambs from immediately after birth to 1 or 2 days after birth. The youngest lamb that we managed to record an EEG from after birth was 3 minutes old. So we were kind of sitting there waiting for the lamb to drop out with our electrodes all ready. And we went right up to 2 days in a group of lambs. And what we found was that the EEG power increased and the EEG developed over this period from birth to the first 1 or 2 days of life. So even though these animals have got all the anatomical bits and pieces in their central nervous systems that they would need to perceive and to be conscious, they're not actually putting that together in a functional sense until they're about 1 or 2 days old. For the first day of life or so, they're not able to put all of that stuff together and make conscious experiential awareness. In another part of the study, we measured concentrations in utero and just after birth of the neuroinhibitor allopregnanolone. This is a steroid, and it's a very similar molecule to a molecule that was developed 20 years ago as a general anesthetic, and is a very good general anesthetic. We find it in utero in high concentrations, and we think that it's one of the major reasons. There are 6 or 7 reasons. We think this is one of the major ones that prevents animals in utero from attaining a degree of CNS function that's compatible with conscious awareness. And we found that the plasma allopregnanolone concentrations in sheep are elevated in the first day after birth and reduce over those first 2 or 3 days as the response to noxious stimulus increases. So it's looking like even though they have all the anatomy to be able to function in this way, there are specific inhibitors which are preventing them from functioning in this way for the first period after birth. All of that put together really means that even in the most precocious mammals, conscious perception and suffering probably doesn't occur until sometime after birth. And if that was the end of the story, I would be standing up and saying that these very young animals soon after birth don't need analgesia if they're going to have a noxious stimulus presented to them. And indeed, in terms of farming practice, that the best time to castrate lambs without analgesia would be very soon after birth. But the interesting thing about pain is that there are 2 sets of negative effects of pain. The 2 badnesses of pain, if you like. The first badness of pain is this perceptive badness of pain. I did something and it hurt and I felt it and it was nasty. But there is also a second badness which we call hyperalgesia. Other things which would be painful are more painful after an acute pain stimulus. How many people here have twisted their ankle at some point? And then walked on it 2 hours later or a day later? Is it more painful than normal when you walk on it afterwards? Yep, that's hyperalgesia. That's the mechanism of a normal stimulus or a stimulus that might be a little bit painful being more painful if it follows on from a significant noxious stimulus. And we know that in adult animals, hyperalgesia can carry on for a very long time after a noxious stimulus. There's some really good work that Avra Waterman did in Bristol looking at foot rot in sheep, which is a painful lesion of the feet of sheep, showing that those animals had hyperalgesia even 6 months after the lesion had been attended to and cleared up and completely treated and wasn't visible anymore. Whereas we think that perception goes on in the cerebral cortex, in the higher centres of the brain, we think that hyperalgesia goes on mostly but not exclusively in the spinal cord. So it's a process that's due to a different part of the central nervous system. And when we look at hyperalgesia following noxious stimulus in very young animals, the results can be surprising. There are a number of medical studies in the literature at the moment. This is probably the best of them, by Baskiller and colleagues in 2003. This looks at the amount of pain found on deep abdominal palpation in young adults, teenagers about 16 years of age. And what they found was that of the teenagers that they looked at, teenagers that had a history of treatment in a special care baby unit had more focuses of pain in their abdomen, and where they felt pain, they described the pain as greater in intensity than adults who didn't have that history of special care baby treatment. So if you're born prematurely and you are exposed to noxious stimulation at a period in your life when you should still be in the uterus, under the influence of all these factors which are reducing your ability to consciously perceive, then the effects of that can last for at least 16 or 20 years, but we think for the whole of your adult life. And indeed, there are studies coming out now that look at the psychological adjustment of these people and finding that young adults with a history of premature birth and special baby care treatment are at greater risk of psychosis and various other psychological disturbances, depression, increased incidence of suicide in that group compared to other people. So these effects are really quite profound. Just want to show you the results of a different study, because this is a study that we mirrored in sheep, and I'm going to show you the sheep study in a moment, but this is the human study. This is the effect of neonatal circumcision on pain response during subsequent vaccination. What Taddeo and her colleagues did was they took three groups of children. The first group, all boys, oddly enough. The first group was circumcised. The second group wasn't circumcised. And a third group, an intermediate group, was circumcised but had local anaesthesia applied at the time of circumcision. And that was all done in the first week of life. Later on, at about 3 months of age, these children were all vaccinated, given routine vaccinations. And when they were vaccinated, they were observed for behavioural signs of pain. And these are the results of facial signs of pain, visual analogue scores. They asked the person doing the vaccination how much pain they thought the child had suffered at vaccination, and duration of crying following vaccination. And what they found for these parameters was that children that were circumcised showed more pain responses than children that were not circumcised. And the children that had local anaesthesia during circumcision were an intermediate group between the two. So what they're demonstrating clearly there is that if you get circumcised, then you are hyperalgesic 3 months later. We wanted to repeat that in lambs, and we wanted to look at the effect of not just castration or not castration, but the age of castration on subsequent pain perception. And so we took 2 groups of lambs. One of them we castrated at 1 day of age, and the second group we castrated at 10 days of age. And then we looked at the effects of tail docking at 1 month of age. Here we've got the incidences of restlessness behaviour. Restlessness behaviour seems to be a really good pain-associated behaviour in sheep, particularly in lambs. And you can see that these are the incidences of restlessness behaviour following tail docking in two groups of lambs. And the only difference between those two groups is that this group were castrated at 1 day of age and this group were castrated at 10 days of age. And it would appear that castrating or providing a noxious stimulus at 1 day of age in very young animals, before they develop this perceptive capacity to feel what's going on, results in more pain-related behaviour to a subsequent noxious stimulus than if they were castrated later on. These animals castrated early are hyperalgesic compared to these animals castrated later. So castration at 1 day of age causes more hyperalgesia than castration at 10 days of age. We don't know why, but we think that this reflects the absence of descending inhibition in those very young animals. There is a mechanism in adults whereby when you perceive a pain consciously, you send inhibitory signals from the cerebral cortex down the spinal cord, and that reduces the response to that pain in the dorsal horn. If you don't perceive that pain in the cerebral cortex, it makes sense that the cortex doesn't then send those inhibitory signals down the spinal cord, and that may mean that the spinal cord is more able to develop this hyperalgesic response than if it was being inhibited. In conclusion then, the definition of an animal in welfare legislation is based on its ability to suffer. Conscious perception of pain appears to develop after birth in all categories of mammals, no matter how neurologically mature or immature they are at birth. And noxious stimulation prior to the onset of conscious perception may cause prolonged hyperalgesia. So that's where we're up to at the moment. Where are we going with this research in the future? In terms of the hyperalgesic side of the response, we're beginning to try and tease apart the age at which the first noxious stimulus is applied and the time lag between the two noxious stimuli. So we're doing a study at the moment where animals are castrated very early and then tail docked at a middle age or a late age, compared to animals that are castrated early and docked at a middle age, or castrated at a middle age and docked later, so that we've got the same time periods between the two events but different ages of animal. In terms of different categories of animals, we're beginning to extend our studies to look beyond mammals and to look initially at birds, and we've got some studies looking at responses to noxious stimulation and analgesia in birds. And also, very recently, just 2 or 3 weeks ago, we started to look at fish. So we're extending outwards from the model of the adult mammal in terms of the phylogenetic complexity of the animals that we're looking at, and we're extending outwards from the adult mammal in terms of the developmental stage that's being looked at.